Welcome. In this session in propositional logic, we'll revisit one of our rules for forward reasoning, and the rule is implication elimination. Let's recall this rule. It says that if we have a formula on one line of our proof, and that formula is the antecedent of a formula that's another line of our proof, we can deduce the consequent as an additional line in our proof. And let's take, for example, this sequent, which is assume T, assume this, and what we want to conclude is R. So let's begin by writing down the premises and write down the conclusion and see where we are. So premise number 1 is T, so that's a premise, and premise number 2 is Q implies T implies that T implies R. So that's also a premise. And our goal for this is we want to conclude R. How could we approach this? Well, we might, for example, try, what we could do is we could use the law of excluded middle, and we could use this consequent as the formula that we're going to draw on. And that's certainly a proof, but that's quite a long one. The point of this session is that we can use implication elimination directly in our proof. So what we could do is we could say, suppose there's a line of reasoning that takes us to the antecedent of this implication. That is, suppose there's a line of reasoning that takes us to Q implies T. If we have this as a line of our proof, and we have this as a line of our proof, we could then conclude the consequent of this premise, which is that T implies R. And we are allowing ourselves to do this, and JAPE, the software that we use, will also allow us to do this. The question is, how can we arrive at this line of the proof? And notice that what we're missing is a lot here, right? We're missing line numbers. We don't have a line number here or here, and we're leaving space because what we have to do is this becomes a new goal formula for us. So if this is our goal formula, the question is, how could we arrive at that goal formula using the rules of natural deduction? And what I would propose is, well, we arrive there by means of implication introduction. So I could write the rule being implication introduction. And if I use that rule, so now what I'm trying to do is backwards reasoning, but usually we do backwards reasoning on the last formula of a proof. There's no reason we can't use backward reasoning in the middle of a proof. And that's really the point here. So if we use backward reasoning, what I could do is I could introduce an assumption box. And my assumption box would look like this. I would take the antecedent of the goal formula and put it as the first line of the assumption box. I would take the consequent and put it as the bottom line of the assumption box. I would note the reason for introducing this, and the reason is it's an assumption. In this case, I would assign a line number to it, and that would be line 3, and I would then examine what I have, and in particular, I would say, what can I do with the new assumption and or with the new goal formula and everything that precedes it that is within scope? Well, if I look at Q and Q implies T, that's not going to get me anywhere. Indeed, that's my goal. And if I look at Q and T, I don't get anything. If I look at T and this, I don't get anything. But T and T, well, that's the same thing. And we rarely use this on paper, but this is an example of where we can use the copy rule. And the copy rule is in the textbook. We don't have a session on it because it's so rarely used. So what I could do is I could say, well, I can justify line 4 because it is line 1 and it's a copy of line 1. And so if I do that, I've completed this assumption box, and I now have a line of reasoning that takes me to Q implies T. Now, if you were reading this proof from the first line onward, you would wonder, why are they introducing this Q and then deducing T? Well, certainly it follows under the rules, but it's in this kinetic motion that you can understand where it comes from. So now I've filled in the rule for the bottom line of the assumption box. That means that I can fill in the justification, so that is using a box of lines 3 through 4 on implication introduction, and then I can now conclude this, and I have this, so it now has a line number. And now I can say, how did I get T implies R? Well, I got it by applying line 5 and line 2, and that was implication elimination. So this is now looking like a strong proof, so that would be line 6. And then how can I deduce R? Well, I have T implies R, so I can deduce R by using line 1, line 6, and implication elimination. And I can assign that as line 7, and now I've completed my proof. So all of this, so this is actually a very short proof compared to one that uses the law of excluded middle, which law of excluded middle is almost invariably followed by disjunction elimination, which is multiple assumption boxes and a little more machinery. Now what we've been able to do is, by applying the rule of implication elimination in the middle of a proof, we have an elegant demonstration of this sequence.